Welcome to the lesson on the cross product. You can recall that we already came up with a way of multiplying two vectors, right? If you have two vectors A and B, then we know you can do what we call the dot product. And this was useful for a couple reasons. It allowed us to calculate the angle between two vectors, it allowed us to do vector projections. But what's sort of interesting about the dot product is it took two vectors and it produced a scalar. Right? You got a scalar answer, which it's a little bit different than if you add two vectors you get a new vector. If you subtract two vectors you get a new vector. But when we multiply or do a dot product, we get a scalar, which is a little bit strange, I guess. So there's actually another way to, you can think of multiplying two vectors, and this is what we call the cross product. So sort of the physical interpretation, or like geometrically what's going on, is you're going to take two vectors A and B, and now these vectors must be in R3. Okay, so A and B in R3. So that's something sort of unique to cross product. It only works in R3. So you've got two vectors in R3. Now, we've seen questions where you're given two vectors, you wanted to find the vector perpendicular to both A and B. So this is perpendicular to this vector B, and it's perpendicular to this vector A. So that's what the cross product is going to produce this new vector. So this is the way we write it. We write A cross B. So cross, it's like the multiplication sign. But in terms of vectors, it means the cross product is perpendicular. So that's a symbol for perpendicular to both A and B. Okay, so that's what a cross product is. Now you might recognize or notice here that this is vector A, this is vector B. There's actually a lot of vectors which are perpendicular to A and B, right? Any multiple of this vector is also perpendicular to both, or any vector going in the other direction. So the way we're going to define the cross product is that A cross B will follow what we call the right hand rule. Follows so the right hand rule sort of is kind of disadvantage to doing this on the video, but if A was your index finger, so index finger, you know what? Sorry, A is not your index finger. A is your thumb. Or, no, sorry, A is your index finger. So index finger. I was right. And then B was your middle finger. Then A cross B is going to be the vector in the direction of the way your thumb would go if you're using your right hand. Okay, so this is A cross B. Now if you kind of think about it, if we reversed A and B, so what if A and B reverse? So what if you wanted to do B cross A? Well then this is going to become your index finger, and this is going to become your middle finger, and then your thumb would now be pointing down. So B cross A would actually be the vector going sort of in the opposite direction of A and B. Okay, so that's the kind of the geometric interpretation of cross product. Okay, so now our challenge will be to kind of come up with a nice, neat formula for cross product. So geometrically we see it's perpendicular to A. It's the vector perpendicular to A and B. But we want, a way to actually multiply, right? Well, how is this a product? Well, remember we've done a question like this, right? With dot product, we said if you have two vectors, A and B in R3, and you want to determine a vector perpendicular to both. Okay, so let's let V be the vector perpendicular to both. So the coordinates of V will let be X, Y, Z, or the components. So now what's going to be true about A, B, and V? So if A and B are both perpendicular to V, then we know that this is the same as what we did in a previous question. That A dot V is equal to 0, the scalar, and B dot V is equal to the scalar. So we're going to use these two facts to come up with our formula for cross product, right? Because cross product will be the vector that's perpendicular to A and B. Okay. So now let's just use the coordinates we have. So A is A1, A2, A3 dot X, Y, Z, and that should be equal to 0. And then the same for B. B1, B2, B3 dot X, Y, Z. That should be equal to 0. So now let's actually do the dot product. So that'd be A1X plus A2Y plus A3Z equals 0. B1X plus B2Y plus B3Z is equal to 0. So now we have these two equations, and notice we still don't know X, Y, and Z, right? We got a lot of unknowns. Well, we can simplify this a little bit. Okay, so we could eliminate a variable in this case. So let's try to eliminate the first terms. So think of it as like doing elimination. So what do I need to do to this and this to make them the same terms? So I'm going to multiply this equation by B1 and this equation by A1. So if I multiply this equation by B1, I'll have A1 B1X plus A2 B1X plus A3 B1. Oh, sorry, that was an X. This was a Y. And then this is Z. And then the second equation would be A1 B1X plus A1 B2 Y plus A1 B3 Z equals 0. So now I have this equation and this equation. So these two equations. So notice that this term here and this term here are the same. So what we're going to do to help us eliminate some of these variables is to just subtract these equations. So I'll call this equation 1, and then this will be equation 2. So A1 B1X plus A2 B1Y plus A3 B1Z equals 0. Now I'm just going to, so just like elimination, subtract vertically. So these two terms will go away, and then I'll have A1 B2Y, so this minus this, A2 B1Y plus A1 B3Z minus A3 B1Z equals 0. Now notice I've got Y in both these terms, Z in both these terms, so I can factor. So Y times A1 B2 minus A2 B1 plus, and then factor out the Z, so A1 B3 minus A3 B1 is equal to 0. So rearranging this, So just doing some rearranging, moving, subtracting this from this side, and then dividing, cross multiplying, you're going to get this. Y is equal to A1 B3 minus B1 A3, and then that would equal Z over A2 B1 minus A1 B2. So all I did was I subtracted this. I kind of moved. You're not really moving, but this would go over here, and then you divide both sides by this. You end up with this nice equation. Okay. So notice this one has y and z. But if you think back to when we initially eliminated these two terms here, we could have eliminated something else, right? We could have eliminated the y's or the z's. So if you had done that, if you had eliminated the y's, let's say the y's, so then you would have had x and z in this equation. You would have got x would also be equal to these things, and x would be a2 b3 minus a3 b2. If you don't trust me, you can go back and verify that fact. So you will end up with this relationship. So x over this, y over this, z over this. So these all have to be equal. The question is, what do they equal? They're going to be equal to some number k. Remember what we're doing here? We're thinking about, remember vector A was a vector in R3, and vector B is a vector in R3, and this vector x, y, z, which we called V, so this is the vector x, y, z, that's what these letters come from, is the vector perpendicular to both. But remember, there's lots of vectors perpendicular to both, right? Just the difference would be the height. Well, that's what the k is going to do. It's going to change the height. So whatever k is, it's just going to make this vector bigger or shorter or in the opposite direction. So for the sake of simplicity, what's the easiest thing you could let k be equal to? Probably 1, right? Let k equal 1. So if k is equal to 1, then x over a2 b3 minus a3 b2 is equal to 1, which means x equals a2 b3 minus a3 b2, and then similarly you could do the same thing for y. Y would equal a1 b3 minus b1 a3, and then z would equal a2 b1 minus a1 b2. So this right here is your cross product. This is the vector x, y, z, which will give us a vector perpendicular to a and b. And this is your cross product. So remember, there's lots of vectors that are perpendicular. This is the vector that we will make the cross product. So let's just write that down as a nice rule. So A cross B is equal to, the x coordinate is a2 b3 minus b2 a3. The b coordinate or y coordinate a3 minus, or a3 times b1 minus a1 b3, and then the last coordinate a1 b2 minus a2 b1. Okay, so this is how you do the cross product. I know it looks daunting at first. You see it, you say, how am I supposed to remember that? We're going to come up, once you do it a lot, you actually find that it kind of makes sense, the pattern. So it's not that hard to remember. And I'll give you a trick sort of in the next one, which a lot of people use to remember it.